Given the rational function, find all asymptotes, either vertical, horizontal, or oblique. Remember, we can have either horizontals or obliques, but we cannot have both. And as a reminder, the reason for that is that we get horizontal asymptotes if the degree of the top and the bottom are the same, or if the degree of the bottom is bigger. But we get an oblique asymptote if the degree of the top is bigger, so we couldn't possibly have both horizontals and obliques. We get one or the other. In this case, we can see that the degree of the top is bigger, so we have the situation where we're going to have an oblique asymptote. But before we get started, the first thing that we want to do is to simplify the rational function as much as possible, which means that we're going to factor the top and the bottom, and then cancel any common factors. So let's start there. In the numerator, we have the special case factorization that is the difference of cubes. That's going to factor into a binomial, which is the cubed root of the first term minus the cubed root of the second term, times a trinomial, which is this quantity squared, then the product of these two things, and then that second term squared, and the signs follow the SOAP acronym, same, opposite, always positive. So this is going to be the opposite of the original sign in here, and then this sign is going to be always positive. So back up here into our rational function, the numerator is going to factor into a binomial, which is the cubed root of the first with the same sign, the cubed root of the second term, times a trinomial, which is this quantity squared. We had the same sign in here, so this one is going to be the opposite, which is plus. Then we multiply these two terms together to get 2x. This sign is going to be always positive, so plus this quantity squared, which is 4. Now the denominator is going to factor using our regular methods. It's going to factor into x plus 5 times x minus 2, two factors of 10 that subtract to 3. And then we notice that we have a factor of x minus 2 that cancels out. So we will simplify this to being x squared plus 2x plus 4 divided by x plus 5. But since we lost the domain restriction that x could not be equal to positive 2, that has to be manually applied to the end to ensure that the graph of the simplified version matches the graph of the original version. Let's start with the vertical asymptotes. The vertical asymptotes are going to occur at the zero of the factor that remains in the denominator after the simplify step. So that would be at the value x is equal to negative 5. Negative 5 is removed from the domain using a vertical asymptote. The domain restriction that was lost in the simplify step is going to be removed from the graph with a hole, not a vertical asymptote. Now remember, we have an oblique asymptote, not a horizontal. And in order to find the oblique asymptote, we're going to need to divide the improper rational function. Now we could carry out that division with the original version or the simplified version. I'm going to use the simplified version to get all my asymptotes. So basically we're going to be dividing the numerator by the denominator. The numerator is the dividend and the denominator is the divisor. Since the divisor is linear, we can use synthetic division here. With synthetic division, we start off with the backwards L and the 0 of the divisor goes into the box. The coefficients of the dividend are written to the side here, and we leave a lane of space with a horizontal line. We start by bringing down that first coefficient of a 1. Negative 5 times 1 is negative 5, which comes up underneath the next coefficient. And then we combine down again to get negative 3, multiply on the diagonal to get positive 15, and combine down again to get positive 19, and this last number is always chopped off to be the remainder. The oblique asymptote is going to be the equation that y is equal to whatever the quotient is we get when we divide. And in this case, our quotient is going to be linear because we had a second degree dividend divided by a first degree divisor, which means that the quotient must be linear. So 1 is the coefficient on x to the first power, and then negative 3 is going to be the constant. Remember, the remainder does not play a role in finding the oblique asymptote, so the oblique asymptote is just going to be the line y is equal to x minus 3. So let's formalize this up in our answer field so that we can clearly state our answer.